All right, welcome to the worksheet on graphing rational functions. We're going to graph these 8 equations, and the mission here is to label the asymptotes and at least 2 points. Minimum of 2 points. You can label a couple of more. And basically I'm going to talk you through number 1, and then you can do 2, and then I'll talk you through 3, and then you can do 4, etc. Through onto the back side. Okay, so here's number 1. The first thing we learned is that we can represent this a different way. So x, there's like invisible parentheses here. You're going to divide x into x, which would be 1, and you're going to divide x into 3, which would be 3 over x. So we learned that when x becomes really super large, then this is going to become 0, and it's going to level off at 1. So the level off point will be 1. That's the horizontal asymptote. So I'm going to make a dashed line here, and it's going to level off at y equals 1. Also, we cannot divide by 0. So if x was equal to 0, that would be a problem because I'd be dividing by 0. So x equals 0 is the vertical line, which is just the y-axis. So x equals 0 is the horizontal asymptote. I mean the vertical. So I'll call this the VA, vertical asymptote, and this is the HA, the horizontal asymptote. So then the curve is going to be in these areas like so. But these are the 2 boundaries, the horizontal one and the vertical one. So I'm going to type this in, and parentheses would be parentheses x plus 3 divided by x. And all of these do on zoom standard, so just zoom and 6. So you can see right here how it bends. It bends away from 0 and how it bends away from 0 there, and then it doesn't cross the 1 line. Now we just need a couple of points. So hit the trace key with me, and how about like a point in here? So I'm going to put 2 in. So if I put in 2, I get 2.5 back. So I'm going to go over 2, up 1, 2.5. So that's where it goes through, and then I know that it's in this boundary area here, so I'm just going to make it curve like so. And so this point here is over 2, up 2.5. And I got that straight off the calculator. So it says label the asymptotes. I got the horizontal one and the vertical one. I labeled that. And then I put a point there. But notice the graph is over here too, so I need a point over there. So how about, let's see. Well, the best point to use would be -3, because -3 plus 3 would be a 0 of the function, and you can see it crosses at -3. So to prove that, -3 goes in, out comes 0. So -3, 0 is a point here. 1, 2, 3, negative. And so it's going to curve in this area like so. And it doesn't cross there, doesn't cross there. All right, and this is the point -3, 0. So I've done the things I was supposed to do. I labeled a couple of points, 1 in each section. So you do the same thing with number 2. Number 3, this doesn't divide into there. If you notice a pattern with this, when the exponents are the same, like that's x to the first, that's x to the first, we can divide. But when the exponent is larger on the bottom than the top, you can't divide it. So it'd be kind of like a single-digit number 5 divided by a 2-digit number 17. You really can't divide that into there unless you start using decimals. But if you had 50 up here, then you could divide 50 into 17. But if it was just 5, you can't. So that's kind of the concept here, is that when these are both the same exponent, you can divide them. But if this is a smaller one and that's a bigger one, you can't. So we're really pretty much done with that. So let's see. Equals 0, that would cause the vertical asymptotes. So 3 and -3. So if I have 3 squared and -3 squared, that would be 9, and 9 minus 9 is 0. So I go over 3 and put a dashed at 3, and then one at -3. So x is equal to 3, x is equal to -3. Those are the horizontal asymptotes. Why did I write horizontal? Mr. Jackie's tired. It's been a rough week of sleep with the time change. Vertical asymptote. And then where's the horizontal one? Well, what would happen was if you were to divide this into here, you would get 0 plus x minus 2 over x squared plus 9. So if you divided it to write it like this here, how we divided it and wrote it 1 plus that, well, down here it's the same thing. We got 0 plus this, so it's at 0. So the horizontal one is at 0. So this is at y equals 0, and that's the the horizontal asymptote. All right. So now I'm going to type it in and get some points and then figure out where it goes. So make sure you use parentheses. We got x minus 2. Close the parentheses, and then divided by parentheses x squared minus 9. Close the parentheses, and graph. This makes kind of a funky graph. So there's a section there, there's a section in the center, and there's a section on the outside. All right, so I'm going to label 3 points because it makes sense to do that. The first point I'm going to put in here, let's see, negative 1, 2, 3, how about -4? That works. -5, we'll do -5. So hit the trace key, -5, enter, and it's pretty close to 0. -0.4. So I'm going to go over 5, 1, 2, 3, 4, 5, and I'm going to go down right in here, and then it's in this section right here. All right, so it's stuck in that section right there, and this would be over 5, -5, comma, -0.48, and that's rounding. I rounded it there. Then we got this S snaky curve in the middle. Well, look what it does, because 2 minus 2 is 0. It's going to cross at 2. So you can see that right there. 1, 2. You can see it crosses right there. To prove it, hit the trace key, type 2, enter, 2, 0. So it crosses at 2, 0, which would be right there. And it does this snaky thing, and it's really close in there, and then it comes down like so. Now that's not a perfect graph, but it's ish. So that would be 2, 0. And now a point over here, which is up in this section here, so I don't know, we'll do 5 again, and that's point, we'll say 0.19, we'll round to 2 decimal places. So 1, 2, 3, 4, 5, it's just up a little bit, so it curves in here like so. And then this point right there is over 5, comma, up 0.19. All right, so that one I labeled 3 points. All right, to the back, here's where we do the whole division thing like we've been practicing. There's not a lot of space right here, so I'm going to bring out another piece of paper so I can divide this properly. So it's x plus 2 divided into x squared plus 2x plus 6. And that's what you'll do on this number 6 here. So it's x squared plus 2x. Ooh, that's weird because the whole thing's going to go away. 6 drops down, you can't divide it. So it's 6 over x plus 2. So this is equal to x plus 6 over x plus 2. That one divided out really fast. So what's going to happen here is when this becomes really super large, you're going to get this oblique asymptote. So it's the oblique asymptote, or diagonal asymptote, whatever you want to call it. And that's at x. That's at y equals x. Well, y equals x is a 45-degree sloping line, right? It starts at 0 with a slope of 1. So it just slopes across like this. All right, so that's y equals x. And that would be the diagonal asymptote. Then negative 2 plus 2. Negative 2 plus 2 would make the bottom 0, and you can't divide by 0. So negative 2 is the other boundary. Put a boundary here. So that's the, let me get it straight this time and think, VA, the vertical asymptote. So there's a boundary here, and there's a boundary diagonal like so. So you're going to get one of the swoopy things in the two parts. Well, let's see what it is. So we go here, and we do x, parentheses first, of course, x squared plus 2x plus 6, close the parentheses, divided by, parentheses, x plus 2. Agree? Yes, that's right. Now graph. So we're going to get this shape right in here, and then we get the other shape over here. So one shape's in here, and the other shape's up there. So I just label 2 points. I don't know, trace negative 3. Negative 3, how about negative 4? Negative 4 is negative 7. So I'll go over negative 4. 1, 2, 3, 4, down 7. 1, 2, 3, 4, 5, 6, 7. So it's going to curve in this space like so. Okay, and this is negative 4, negative 7. Then it's going to curve in here. And how about if I just put in 0? 0, enter. 0 is positive 3. That makes sense because it'd be 6 over 2. So 0, 1, 2, 3. So I found the y-intercept. And that's at 0, 3. All right, so the graph is down here. The graph is there. There's the diagonal line. The next two are the most basic ones of all. You don't even really need a calculator for this. You can't divide by 0. So 0 is the x equals 0 is the vertical asymptote. And then again, when the exponent on the top is smaller than the one on the bottom, you would represent this as 0 plus 2 over x. So it's at 0. See, this one was at x, this one was at 0, that one was at 1, right? So when you divide it out, when you divide this out, you can't divide it out. So 0 is the horizontal boundary. So y equals 0 is the horizontal asymptote. There, I got my horizontal and vertical figured out. Then you just need some points. So the points here are real easy. Put in 1, 1, 2. All right, so put in 1 for x. Here, I'll make a little table. Don't need no stinking calculator. 2 divided by 1 is 2. If you put in 2, you get back 1, right? So we go over 1, up 2, over 2, up 1. So it curves in like this. And then the negative versions of that would work. If you put in negative 1, you get negative 2. Put negative 2, you get negative 1. So it flips over here. So 2, 1, 1, 2, and like so. All right. So there we go. There's the answer. Now you work the other ones. Ba-boom.